Welcome to Spelling Bee Ninja. If you're eager to learn more about the fascinating world of logic and critical thinking, you've come to the right place. Join us as we explore the intricate connections between cause and effect in our daily lives. By subscribing to our podcast, you're choosing to empower yourself with knowledge. So let's dive in and unlock the secrets of causation together. Today, we're going to delve into cause and effect. Have you ever thought about how events connect with one another? That's what cause and effect is all about. A cause is an action or event that initiates something else, while an effect is the outcome that results from that initial action. This understanding is not just essential for logical thinking but also vital for fields like science, problem solving, and even history. For instance, when you study hard, that's the cause, and receiving good grades is the effect. Similarly, consider a chef who forgets to set a timer. The cause here is the missed timer, and the effect is burnt food. This simple yet profound relationship is foundational for making sense of the world around us. Did you know that the ancient philosopher Aristotle identified 4 different types of causes? Among these, the efficient cause is the one we're most familiar with. It refers to the entity that directly brings about change, like our chef who forgot the timer. Understanding these relationships can empower us to predict outcomes and improve our decision-making processes. Next, let's talk about causal chains, which often show us how one event can lead to a series of others. A single cause rarely leads to a singular effect on its own. Instead, we typically encounter chains of causes and effects. For example, when a power outage occurs, food in refrigerators spoils. That's the first effect. Families then eat out as they can't cook, which leads to busier restaurants and more tips for waitstaff. This cascading sequence of events illustrates why it's crucial to appreciate the impact of even small actions. Interestingly, there's something called the butterfly effect from chaos theory that suggests that a tiny change in one part of the world, like a butterfly flapping its wings in Brazil, could eventually lead to a massive effect elsewhere, like a tornado in Texas. Although metaphorical, it highlights how interconnected our world truly is. Now, let's consider the notion of multiple causes. Oftentimes, significant effects arise from numerous contributing factors rather than a single cause. This is referred to as multiple causation. For example, a student might receive a poor grade because of several reasons like lack of sleep, anxiety during the test, unclear instructions, insufficient study time, and tough material. Similarly, public health issues like cancer arise from a combination of genetic, lifestyle, and environmental factors. The tragic sinking of the Titanic in 1912 is a historical example where multiple factors contributed to the disaster. High-speed sailing, crew errors, and insufficient lifeboats all played a critical role. Recognizing these multiple causes frees us from oversimplifications and allows for more effective solutions. Moving on, let's address a common logical error: confusing correlation with causation. Correlation refers to 2 events occurring together but doesn't imply that one causes the other. For instance, you might notice that both ice cream sales and shark attacks increased during the summer months. Does this mean that eating ice cream leads to shark attacks? Not at all. Both are influenced by warmer weather, which attracts more people to the beach. Likewise, a study found a correlation between chocolate consumption and the number of Nobel Prize winners. Does this mean eating chocolate makes you smarter? Likely not. The correlation is probably due to wealthier countries having better education systems while enjoying more chocolate. That's where the common phrase, cum hoc ergo propter hoc, comes into play, meaning with this, therefore because of this. It's important to question these relationships. Is there a hidden factor? Could the relationship be reversed? Perhaps it's merely coincidence? Another fallacy to watch for is the post hoc fallacy, which occurs when we mistakenly believe that because one event followed another, the first event must have caused the second. For instance, if you wear a new shirt to school and have a great day, you might think the shirt caused your good fortune. In reality, that day could have just been great for many reasons unrelated to your outfit. In ancient Rome, astronomers noticed that eclipses often coincided with political unrest. Many erroneously concluded that eclipses caused unrest, not realizing both were driven by the same societal issues. David Hume, a well-known philosopher, insisted that we can't directly observe causation, we only witness events in sequence and naturally link them together in our minds. To prove causation, we need more than a mere timeline of events, we need concrete evidence of mechanism and controlled conditions. Next, let's look at proximate versus ultimate causes, which is another crucial distinction. Proximate causes are immediate and direct, while ultimate causes refer to deeper, more underlying reasons. A doctor might say a patient died from a heart attack, which is the proximate cause, but the ultimate cause could be years of poor diet and lack of exercise. In the context of evolutionary biology, understanding these layers is vital. Proximate causes explain how things work, such as why birds migrate due to daylight changes, while ultimate causes provide context on why these traits evolved in the first place. This distinction, established by biologist Ernst Mayr, greatly influenced biological sciences and other domains. It's essential to address both types to discover lasting solutions to problems. Testing causation is a rigorous aspect of the scientific method. Scientists conduct controlled experiments to establish whether a cause-and-effect relationship is genuine. One of the most reliable methods is the randomized controlled trial, where participants are randomly divided into groups to test treatments versus placebos and compare the resulting outcomes. Historical experiments, such as James Linn's in the 18th century, demonstrated that citrus fruits cured scurvy. However, it took decades for practical applications to follow these findings. When experiments aren't feasible, researchers use statistical methods to isolate variables and follow established criteria to assess causation, like the principles laid out by Sir Austin Bradford Hill. These principles guide scientists in determining whether a real causal relationship exists. It's also important to be aware of common causal fallacies to avoid being misled. Both the cum hoc and post hoc mistakes we discussed are among the most common. There's also the single cause fallacy, where one assumes that a complex effect arises from a single cause, and causal oversimplification, disregarding the interplay of multiple factors. A historical example is the Tuskegee study of untreated syphilis, conducted from the 1930s to the 1970s. The flawed reasoning behind the study caused immense harm because researchers failed to consider environmental factors that could better explain differences in health outcomes. Today, ethics ensure that similar mistakes are less likely. As we wrap up, consider how understanding cause and effect shapes our everyday lives. It aids doctors in diagnosing illnesses where symptoms represent effects leading to identifying underlying causes. Engineers rely on causation principles in design to prevent structural failures, while parents teach valuable lessons about actions and their consequences. Public health as a discipline emerged from unraveling health issues like cholera, traced to contaminated water in the 19th century, paving the way for sanitation systems that have saved countless lives. Similarly, the long-established connection between smoking and lung cancer has prompted successful public health campaigns to reduce smoking rates. When weighing decisions, critically analyze potential effects and the real causes of challenges. This practice benefits all aspects of life. Mastering the ability to discern these relationships fundamentally alters your perception of the world. Start by considering, what is the cause? What is the effect? What is the evidence that ties them together? From there, ask if there might be multiple causes, if a hidden factor exists, or whether the correlation is truly causal. By practicing this logical analysis with news stories, ads, and political claims, you can enhance your critical thinking skills. Remember, John Stuart Mill developed 5 methods for establishing causation, known as Mill's methods, which remain influential today. The more you engage in this kind of thinking, the more intuitive understanding cause and effect will become, ultimately empowering you to navigate the world more astutely. To summarize, we explored the foundational concepts of cause and effect, including the significance of understanding causal relationships in our everyday lives. We discussed how events are interconnected through chains of causes and effects, as well as the importance of recognizing multiple causation and distinguishing between correlation and causation. We touched on common logical fallacies that can lead to misunderstandings and the significance of both proximate and ultimate causes in analyzing situations. By mastering these concepts, you can make more informed decisions and develop critical thinking skills that enhance your perception of the world. Thank you for joining us today on Spelling Bee Ninja. If you enjoyed today's discussion about cause and effect and want to dive deeper into more fascinating topics, be sure to subscribe so you never miss an episode. Keep questioning, keep learning, and until next time, continue exploring the intricate relationships that shape our lives.